Mars is the Earth's space cousin. It's the fourth planet in our solar system, about half the size of the Earth. It also has two small moon buddies, Phobos and Deimos. These moons are shaped like potatoes. Phobos is the drama king, moving closer to Mars and planning a crash landing in about 50 million years. Deimos is much calmer though, hanging out farther away from Mars. Mars got a cool nickname, the Red Planet, thanks to its rusty red surface. This color was so bright that it was spotted by astronomers many years ago. Even you can sometimes see it in the sky with the naked eye, a small scarlet dot. And maybe it has hot vibes, but in reality, Mars is a very cold desert. The temperatures there can drop as low as minus 240 degrees Fahrenheit. But was Mars always nothing more than a rusty-looking desert? Actually, no. Scientists believe that perhaps many years ago, this planet was similar to ours. Meet Curiosity, the detective rover made by NASA's Jet Propulsion Laboratory. Scientists want to know all about the Martian weather, landscape, and other stuff like that. Curiosity is a pretty heavy car-sized robot. It weighs about 1,985 pounds. It embarked on its journey on November 26, 2011. The rover pulled off a landing on Mars on August 6, 2012. Originally, Curiosity's mission was supposed to last for 2 years, but it's still going strong. Curiosity is basically a space lab on wheels. It's packed with cameras, spectrometers, radiation detectors, and sensors to sniff out the Martian environment. As Curiosity roams around, it rewinds Mars history. And during its mission, the rover discovered something incredible: signs of lakes and rivers from long ago. You see, Curiosity's favorite spot to play around is Gale Crater. It's a prehistoric Martian oasis where water might have hung out. There's this huge mountain in the middle called Mount Sharp. This place is taller than 10 Eiffel Towers stacked on top of each other. And it's got layers of rocks that hold Mars's ancient secrets. Recently, scientists spotted something great when studying Curiosity's data: mud tracks. What's so surprising about that? Well, these aren't just any old tracks. They're like messages from the past. They mean that the Martian ground used to get wet and then dry out again. The mud on the ground would shrink and crack during the drying phases, making these T-shaped junctions. Moreover, it seems like the ground on Mars went through several wet-dry cycles. It happened maybe up to 10 times. This made the junctions turn into Y-shaped cracks. When a bunch of Y-shaped cracks got together, they made a super cool pattern, something like a patchwork of hexagons. It looked just like honeycombs, or even a dragon's skin. Each of these hexagons are the size of candy. Similar cycles have happened on Earth, and they're linked to the birth of life. When water dries up, it leaves behind concentrated stuff that's great for chemical reactions, and these reactions might be the same ones that kickstart life. These hexagons have been hanging around for a really long time, billions of years. That means that Mars once had a climate kind of like Earth's, and maybe even life. In fact, the Red Planet even has some signs of water right now, in the form of hidden ice at the poles. Mars has the North and South poles, and just like with the Earth, they're Red Planet's ice caps. Picture the North Cap as a big, icy pancake about 620 miles wide. The South Cap is a bit smaller, about 220 miles wide, but it's got a thicker ice layer, almost like a snowball with a strong shell. When it's winter at the poles, it's an incredibly long nighttime. No sunlight, just chilly darkness. During that time, around 30% of the air turns into frozen CO2. It's dry ice, the same stuff that's often used in horror movies. But when the poles wake up to sunlight, the dry ice turns back into gas. All this freezing and thawing makes clouds and frost, just like on Earth. One time, a rover named Opportunity even caught some clouds made of water ice. But it doesn't necessarily mean Mars was once thriving just like the Earth. Life needs more than just wet-dry cycles to pop up. It needs the right atmosphere and other special ingredients. We're not sure if Mars had all of those, and even if it did, there's no guarantee that life actually happened. But this raises another very important question. has Mars ever hosted tiny living creatures? Curiosity isn't the only robot that tries to find the answer to that. There's also a rover called Perseverance. It's trying to find clues about Martian life. It's digging into an old Martian crater once filled with water. And like a space archaeologist, Perseverance is searching for fossilized signs of ancient critters. And here's the funny thing. Some scientists think that we've stumbled upon it almost half a century ago. The only problem is, we might have accidentally destroyed it. It happened even before Curiosity started rolling around Mars. Back in the 1980s, two cool NASA's landers, Viking 1 and Viking 2, made a pit stop on the Red Planet. These landers took a selfie, and then they also did some funky experiments on the Martian soil, all in the name of finding signs of life. What they found is some weird organic stuff called perchlorate. It's a compound that we use in fireworks or rocket fuel. But most results didn't seem that promising. They even mixed up some soil with water and nutrients, hoping that if there were Martian microbes, they'd snack on the goodies and return radioactive gas as a result. But unfortunately, that didn't happen. Now, here's the problem. Some scientists think that maybe the water they added back then actually destroyed those tiny Martian critters. Poor microbes were just hanging out and suddenly got soaked by a bunch of weird liquid. Something like this wouldn't be very pleasant for the Earth microbes. They live inside rocks and they're sucking water from the air. Pouring water on them would result in a total disaster. So, of course, giving them nutrients after that wouldn't do anything. If you've just barely survived a water bath, you're probably not in the mood for a feast. Perhaps these Martian buddies might have something called hydrogen peroxide in their cells. It helps them live in an extreme environment. If that's true, it could explain all the results from the experiments. You see, the instruments heated up the samples, so if there was hydrogen peroxide, it would have gone boom, wiping off the little guys and turning their cozy homes instantly. Imagine how ridiculous it would be if it turns out that we accidentally destroyed the only signs of life on Mars. Ideally, we need a new mission to Mars to test this theory. Let's hope it's not true. In any case, the journey isn't over. There are more missions planned for Mars, and humans might even visit this planet someday. The next mission is the Mars Sample Return. It's a super cool teamwork project between NASA and ESA. They're teaming up to bring back souvenirs from Mars, collected by NASA's trusty Mars Perseverance rover. There's going to be a whole bunch of spaceships. They'll work together to bring these precious Mars samples back. The samples are planned to arrive on Earth in the early to mid-2030s. And the fun doesn't stop at Mars. Our Mars missions are a warm-up for an even bigger adventure, exploring icy moons around Saturn and Jupiter. These moons have hidden oceans beneath their icy surfaces, and who knows what kinds of space secrets they're hiding. But whether it's Mars, icy moons, or beyond, our quest to find extraterrestrial life continues. In addition, we are slowly starting to find more and more organic materials on Mars, and maybe one day we'll finally find some microbes in our solar system. Let's hope for it and stay tuned.
The soil beneath your feet is red and dry. The place is freezing cold. Rusty-colored dust is floating in the air. You make one step, then another. It's hard to move because of the thick layer of dust your feet are sinking into. You're on Mars, and you've come here after hearing some absolutely incredible news. These days, the so-called red planet indeed looks dry and dusty. But scientists think that this world might have been very different a long, long time ago. They have found some evidence of a huge ocean that could have existed on the surface of Mars about 3.5 billion years ago. And this ocean probably covered hundreds of thousands of square miles. It all started with numerous satellite images of the surface of the red planet. They were snapped at different angles. As a result, researchers managed to construct a relief map of the area. They charted out more than 4,000 miles of specific formations that had most likely been carved by rivers. Those formations could also be channels, once carved out on the sea floor. Scientists used the data gathered by the Mars Reconnaissance Orbiter in 2007. They analyzed the thickness of the ridges and their angles and locations. Their main goal was to explore the topographical depression called Aeolus Dorsa. It turned out that all those years ago, this part of the red planet had been undergoing a series of constant changes. They could have been caused by the rapid movement of rocks, pulled around by currents and rivers, as well as noticeable increases in sea level. Researchers also noticed a pretty clear boundary that separated the southern highlands of Mars, elevated and highly cratered, from the smooth lowlands of the planet. It looked very similar to a shoreline left by a ginormous ocean. This all likely means that in ancient times, there indeed was an ocean on the surface of Mars, and a large one at that. What's even more exciting is that the existence of such an ocean might mean the existence of life. This discovery can tell scientists a lot about the ancient climate on the red planet, as well as its evolution. We now know there had to be a period on Mars when the planet was quite warm, and its atmosphere was thick enough to keep so much liquid water. What's even more incredible, the climate in the northern hemisphere of Mars 3 billion years ago could have resembled the one we have on Earth nowadays. But then, where is this ocean now? What happened to it? Perhaps the climate of the red planet was becoming cooler, and the surface of the ocean froze. There's a theory claiming that these days, the ocean remains in its frozen state, deep under a layer of rock, debris, and dust under a northern plain called Vastitas Borealis. Or the ocean's waters could have been lost to the atmosphere, and eventually space through the process of atmospheric sputtering. During this process, atoms get knocked away from the atmosphere after colliding with high-energy particles coming from the sun. Anyway, the theory of an ocean that once covered a substantial part of Mars's northern hemisphere hasn't been confirmed yet. Scientists are still arguing about its existence. As for now, Mars is a very cold world with an average temperature of -80 degrees Fahrenheit. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The ocean that might have existed on Mars isn't the only awesome thing about this planet. Let's speak about those sandstorms raging on the red planet. In movies, they're depicted as incredibly powerful forces of nature, destroying astronauts' camps and tearing their spaceships into pieces. But how much of it is true? Mars is indeed infamous for producing dust storms so massive they can be seen by telescopes on Earth. They sometimes cover continent-sized areas and can last for weeks at a time. But besides them, there are much rarer storms that occur once in 3 Mars years, which is about 5.5 Earth years. Such storms are larger and much more intense than regular ones. They encircle the entire planet. That's why scientists call them global dust storms. At the same time, it's unlikely that even a global dust storm could cause serious harm to astronauts or their equipment. Even though Martian storms are massive, the wind speed reaches 60 miles per hour tops. That's less than half the speed of most hurricane-force winds on Earth. Plus, this comparison of wind speeds can be kind of misleading. The atmosphere on Mars is just 1% or so as dense as the atmosphere on our planet. It means that the wind there needs to blow much faster to cause any damage, or even fly a kite. Now let's move to the next amazing phenomenon spotted on the red planet. When you look at it from a distance, it looks like an eye. There are even some winding channels that look like veins running through the eyeball. But the closer you get, the less the formation looks like an actual eye. It's actually a giant crater, almost 19 miles in diameter. Around the crater, which looks as if it has a pupil, there are other, even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once, water filled the ginormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Your next destination is Valles Marineris. That's an enormous canyon, or rather, a canyon system that runs along Mars's equator. It stretches for more than 2,500 miles. It's also 4 times as deep as the famous Grand Canyon on Earth. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Most scientists think that Valles Marineris is a huge tectonic crack in the crust of the red planet. It could have formed when the planet was cooling down in the distant past. Another breathtaking sight on Mars is the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which means it's almost the same size as the state of Arizona. The mountain is also 16 miles high and rimmed by incredibly tall cliffs. To imagine the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, around 2.6 miles high and 75 miles across, which actually sounds pretty impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. Scientists have been wondering for quite some time why this volcano is so large. It might be the result of lower surface gravity and higher eruption rates. Or the reason may be the red planet's crust, which is very different from Earth's. On our planet, the crust is made up of 15 to 20 moving tectonic plates. As plates move over hotspots that produce lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. Now, if you visited Mars and decided to go on an evening stroll, you'd witness a strange phenomenon. It occurs on the red planet after sunset, when temperatures fall below -80 degrees Fahrenheit. A bizarre, mysterious glow spreads across the Martian sky. Unfortunately, without special equipment, you wouldn't be able to observe this soft glow. Visible only in ultraviolet light, this night glow is the result of chemical reactions that occur dozens of miles above the surface of the red planet.
This planet looks lifeless. Lifeless, brick red, and very, very dry, like a desert. But only until you reach one of the poles of the red planet. That's where you come across a seemingly endless ice cap. So if you've been imagining Mars as an extremely dry place, you might need to change your opinion. Scientists think there could have been a lot of water on Mars in the past. What makes them think so? They found loads of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could have only quantities of water in the planet's atmosphere, but it only exists as vapor. Anyway, now that we know for sure there is liquid water on Mars, could we probably use this water during a human-operated mission to the red planet? This way, the spaceship coming from Earth wouldn't have to bring its own water. It would make its cargo way, way lighter, which in turn would decrease the cost of the mission. The spaceship would just need to take enough water to get to the red planet and bring along the equipment astronauts will need to filter Martian water to make it drinkable. But it's not all sunshine and rainbows. The main problem is that the water found on Mars is salty. It might even be as salty as the oceans on our own planet. But these salts aren't what you can find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then, they could use a UV disinfection unit. This would also help to get rid of any foreign microbes, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars should one of the largest moons of Jupiter. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. There's also some evidence that the ocean might have warm water radiating from the moon's equator, which also means there could be not just life, but complex life on Europa. Well, I guess we'll find all about it in 2030 when NASA's Europa Clipper will reach the satellite and conduct its own investigation. And we're moving on to Enceladus, Saturn's moon. People have known about this tiny sleepy world since 1789. The diameter of the moon is a mere 310 miles, but despite its small size, it's one of the most intriguing places in our solar system because it too is likely to host a warm and salty liquid ocean. Watery eruptions happen on Enceladus rather regularly. The moon spews from its ice geysers more than 1,000 tons of water every hour. This water is mixed with organic molecules, salt, and other substances. Astronomers think that the ocean might be warm thanks to the tidal influence of Saturn. The planet's tug may cause hydrothermal activity, warming the oceans. There are also places in the solar system that might have water on their surface, but its presence hasn't been confirmed yet. For example, Ganymede, another moon of Jupiter. It's the largest moon in the solar system. It's even bigger than Mercury. Astronomers have long believed there is an ocean beneath the 100-mile thick ice crust covering the moon. And in 2015, Ganymede's auroral activity also hinted that this ocean could be warm and salty. Unlike on Europa, ice geyser activity on Ganymede hasn't been spotted yet. The reason might be a much greater distance between Jupiter and Ganymede than that between the gas giant and Europa. Also, there are the maybes. Those are worlds where there seems to be water, but we don't know to what extent it is liquid. One of such places is Callisto, which, have you guessed it, is another of Jupiter's moons. It's pretty far from its parent planet and also doesn't get as much radiation as other moons. Plus, it has a magnetic field, which definitely adds some protection. Astronomers claim there is water in this faraway world, but the moon's lack of geological activity might mean that it can't have an ocean without some kind of space antifreeze. In other words, all that water on Jupiter's satellite can be a huge, and I mean huge, chunk of ice. Now, let's visit another space body, but this time, it's not a moon, but a dwarf planet. Look, this is Ceres. Even though people have known about it since 1801, Its small size made it difficult to study. Until not so long ago, this space body was considered to be a rocky world. But after the Dawn spacecraft arrived at Ceres in 2015 and examined the dwarf planet, a new theory appeared. Ceres might be less of a rocky ball and more of a watery planet covered with an icy mantle and a slushy ocean moving beneath. If it's true, Ceres could become the nearest to Earth world with an ocean. Titan is Saturn's largest moon. It has some of the most abundant pools of liquid in the solar system. Its surface is a slurry of water ice and ice made of lots of different compounds, for example, hydrocarbons. The satellite also has dense clouds that regularly burst with rain. And if you visited this place, you'd see rivers, lakes, and an ocean made up of methane and ethane hiding under the icy crust. Now let's talk about poor Pluto, which has changed its status a couple of times. When NASA's New Horizons flew by the dwarf planet in 2015, it discovered a hint of something totally unexpected: an ocean. Pluto is an icy world. But there are two things that make scientists think that Pluto might have once hosted an ocean. First, a theory that Pluto and its 5 moons could have been formed out of the same materials after a powerful collision. And second, the tidal forces between Pluto and its largest moon, Charon. Even better, this leaves open the possibility that the ocean is still around. We just need more time to examine the dwarf planet.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the 4th planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grain than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient mega-flood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that? Imagine something terrible happening to Earth and humans having to leave it as fast as possible, and you have to decide which planet will become your new home. Which one will you pick? Probably the first planet that comes to mind is Mars. It's relatively close. Like Earth, it's also a rocky planet. It even has an atmosphere, even though it's much thinner than what we have on our planet. But at the same time, the North Pole on Earth would seem balmy to you in comparison to Mars. On the red planet, the average temperature is minus 80 degrees Fahrenheit. The most radioactive areas on our home planet might seem harmless if you compare them with the surface of Mars. But what if we terraform Mars? Could we keep transforming the red planet until it becomes capable of supporting human life? It would be an enormous feat. Mars is an extremely dangerous place. Should you teleport there right now without any protective suit or anything, the gas in your blood would instantly turn into bubbles. You can probably imagine the consequences. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, and well, who's next? If we still decided to terraform Mars, we would need to create a stronger magnetosphere. We've got this protective magnetic layer on Earth. It shields us from the sun's ultraviolet radiation. The red planet would also need a thicker atmosphere, again for protecting us from harmful space stuff better. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. For us to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the red planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Right now, there is some water on Mars. The atmosphere of the red planet is too thin for this water to stay in its liquid form. But under the surface of the planet, it's a different matter. You can find water under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar Ice Cap. Also, sometimes salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. If liquid water existed on the surface of the planet, it would make it easier for us to start growing plants, and plants, in turn, would begin to produce oxygen. But first of all, we would need to start the warming process. How? Well, Elon Musk suggests using nuclear energy to make Mars more livable. He says it could be done by creating a continuous flow of low-fallout nuclear fusion explosions above the atmosphere of the planet. It could create something like numerous artificial suns. It could warm the planet, melting the frozen ice caps, which would then thicken the atmosphere, causing even more warming. Other strategies for Martian global warming include the diversion of asteroids into the poles of the planet, or the large-scale production of greenhouse gases that could help us heat the red planet. Or we could create a giant space mirror, as huge as the side of Mars. It would reflect tons of additional sunlight onto the planet. The problem is all these projects would have exorbitant costs. They would also require serious upgrades in our technological capabilities. Could there be an easier and cheaper way of terraforming the red planet? It seems so. Casey Hanmer used to work in NASA's Jet Propulsion Laboratory. Now he's the founder of a startup hoping to create carbon-negative natural gas by pulling carbon dioxide out of the atmosphere of our planet. He's also made a proposal to terraform Mars for a modest $10 billion. Sounds alluring. So, what is his idea? Mass-produced small solar sails. These are already existing technologies, even though they appeared only recently. Such sails use sunlight to propel themselves, like ships use the wind to sail. These solar sails could be launched into low Earth orbit, and after that, they would fly themselves to Mars. There, they would reflect sunlight onto the night side of the planet. According to Hanmer's calculations, a decade of such launches could result in a 1% increase in temperature on Mars. Hanmer also believes that we could mass-produce solar cells at cell phone factories, all because a solar sail would need a processor, a camera for navigation, and some electronics to be able to transmit data, just like a smartphone. In other words, Solar sails would be like small satellites using cell phone technology. Each of these sails would also need a sail of its own, a thin space blanket weighing about 2 pounds. When unfurled, it would span around the size of 2 basketball courts. Would this plan involving solar sails enable people to terraform Mars? Hanmer doesn't think so. Even if we put loads of money into solar sails, they would only make the red planet warmer and more humid, but they still wouldn't be enough to make Mars suitable for human life. Most scientists are also very skeptical about the very idea of terraforming this cold, dry world. They say that carbon dioxide and water vapor are the only greenhouse gases present on Mars, but there's just not enough of them to change the situation. Let's say we manage to melt the polar ice caps with the help of Elon Musk's nuclear technology or solar sails. And still, this ice will only release enough carbon dioxide to bring the atmospheric pressure to 1.2% of what it is on Earth. Plus, most of the carbon dioxide gas wouldn't be accessible, and we wouldn't be able to mobilize it. Even if we decided to go through an energy-intensive process of the extraction of carbon dioxide from the planet's soil, dust, and minerals, we'd still only get the atmosphere to a mere 5% of where it needs to be. Water is another problem. It is salty on Mars. It might even be as salty as the oceans on our planet. But these salts aren't what you find on Earth. If a person consumed a certain amount of them, they would be highly toxic to the human body. Who's next? On our planet, these salts are formed as byproducts of rocket fuel, as well as in road flares and fireworks. Naturally, they only occur in very dry areas. If there are no particular bacteria to break them down, these substances accumulate year after year, and their concentration in water is constantly increasing. But in theory, it's possible to purify even such water. The process of filtration could help the astronauts get rid of 90% of harmful substances. Then they could use a UV disinfection unit. This would also help get rid of any foreign molecules, if there are any, that might be hiding in the water. This stage would not only protect the astronauts, but also prevent them from bringing any dormant Martian microbes back to Earth. In other words, future travelers to Mars shouldn't have too many problems with drinking water on the red planet, but only if they bring the right purification equipment that can deal with any water quality. Because however bad running out of water in the middle of a desert is, experiencing it on another planet sounds much more terrifying. Anyway, back to terraforming the red planet. Once you start thinking about it, some worrying questions arise. Who is supposed to decide whether we should start this process? When should we start it? What if there's some form of life on the red planet, like indigenous microbes we haven't spotted yet, and our attempts to change their home will disturb them? What if they don't survive these changes? Now, what do you think? Share your thoughts in the comments. It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the fourth planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, It's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years, and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you. Have we found another civilization? Is that a door to someone's home on another planet? Can we peek through the windows? After all, it was NASA's Curiosity rover that sent this image to Earth, and right now, this rover is exploring the surface of Mars. Unfortunately, astronomers were fast to disappoint us. They claimed that it was just a natural part of the Martian landscape. There are several clues that made them think it wasn't a real door. For example, it's tiny, a mere 3 feet high. But it might simply mean the Martians aren't that tall, you may object. But scientists keep insisting that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. The thing is, if you look at the rock attentively, you may notice strata, the layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more, and now you can see that they disappear inside the door. And look at this. See those cracks? Yeah, those. That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. Now, this theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago, and Martian winds haven't got rid of it yet. And winds on Mars can be exceptionally powerful. This planet is infamous for its intense dust storms. Sometimes they kick up so much dust that you can see it through a telescope on Earth. Such storms occur every year and cover continent-sized areas. They also last for weeks at a time. But besides these annual storms, there are even larger storms that happen much more rarely, but they're more powerful and way more intense. Those are called global dust storms because they encircle the entire planet. But even if you got caught in the most severe storm on Mars, it wouldn't be as terrible as you might think. The wind speed on the worst Martian storms reaches 60 miles an hour tops. Hurricane-force winds on our planet can be twice that speed. You should also keep in mind that the atmosphere on the red planet is 1% as dense as the atmosphere on Earth. That's why, if you decided to fly a kite on Mars, you'd need the wind to be much faster than on Earth. Otherwise, you wouldn't even be able to get the kite in the air. In other words, even though it's quite windy on Mars, it doesn't feel as intense as on our home planet. Oh, by the way, you might have noticed I keep calling Mars the red planet. Why? Look, our neighbor is covered in dust, soil, and rock that is rich in iron oxide. That's what gives the surface of the planet its trademark red hue. And look, there's the trademark. Nah, just kidding. Mars is the fourth planet from the Sun. Not so far away from the star, you might say, and still, it's a cold and deserted world. The average temperature on its surface is minus 81 degrees Fahrenheit. But if you ever visit one of its poles during the wintertime, bring a lot of warm clothing, because the temperatures are likely to drop to minus 220 degrees there. In the summer, though, you might feel very comfortable in some regions. There, the temperatures can rise to 70 degrees, not very different from what we're used to. Mars is one of the most explored space bodies in the solar system. At the moment, NASA has 2 rovers roaming the red landscapes, Curiosity and Perseverance. There's also one lander called InSight and helicopter Ingenuity, nicknamed Ginny. Perseverance is the most advanced and largest rover ever sent to another world. The journey to the red planet took 203 days, and Ginny traveled to Mars attached to the belly of Perseverance. Sounds cozy. And now, I'm going to tell you something really curious. Let's say you're a Babylonian who lived around 5,000 years ago. Babylonia was an empire in ancient Mesopotamia. Just think back to 6th grade. Anyway, your neighbor comes up to you and says, "What day is it today?" And what do you answer? "It's Mars Day." Wait, what? When the ancient Babylonians created the week, they decided to divide it into 7 parts. Each day got named after some space body, like the Moon, the Sun, Venus, and so on. Mars Day was on Tuesday. The Babylonians believed that each of these space objects influenced their lives on the day named after it. And since Mars was red in color, they associated it with aggression. That's why on Tuesdays, they had special ceremonies to avoid the influence of the unfriendly planet. Indeed, Mars might seem unfriendly to a tired traveler. Its atmosphere is very thin. Its volume is a near 1% of the atmosphere on Earth. In other words, there's 99% less air to breathe on the red planet. Mars's atmosphere is mostly made up of carbon dioxide. At such high concentrations, it's toxic for us humans. And if you were looking for some oxygen to breathe on Mars, you'd come away empty-handed. There's only 0.1% of oxygen in the air on the red planet. That's definitely not enough for you to survive there. At the moment, Mars has 2 moons, Deimos and Phobos. Astronomers think they may be asteroids once caught in the gravitational field of the planet. The moons are shaped like potatoes. That's because their mass is too little for gravity to give them a spherical form. Potatoes, eh? Maybe they should be renamed mashed and au gratin. One day, Mars will get a ring of its own. It might happen in the next 20 to 40 million years. Will Brightside be there? Stay tuned. Mars's gravitational forces will tear apart the planet's largest moon, Phobos. Hey, it really will get mashed. Some chunks of the former moon will crash into Mars, and others will break apart and create the ring around the planet. This ring might exist for at least 100 million years. The surface of Mars is cut by a huge canyon system known as Valles Marineris. Sounds like a pasta sauce. If it were on Earth, it'd stretch all the way from New York to California, over 3,000 miles. At its widest part, the largest canyon on Mars is 200 miles, and it reaches 4 miles at its deepest point. If you still have difficulties imagining the sheer size of this natural phenomenon, here you go. Valles Marineris is 10 times the size of the Grand Canyon on Earth. Now, since we're on the subject of gigantic things, let's talk about Olympus Mons. This is the largest volcano in the solar system, and it's on Mars too. It's 3 times as tall as Mount Everest on our planet, and that's the tallest mountain above sea level. And the base of Olympus Mons is as large as the state of New Mexico. Now, scientists think there could have been water on Mars in the past. What made them think so? They found lots of ancient river valley networks and lake beds on the surface of the red planet. Plus, on Mars, there are minerals and rocks that could only form in liquid water. Mars might even have experienced terrible floods 3.5 billion years ago. These days, there's still some water on the red planet, but Mars's atmosphere is too thin for this water to stay in its liquid form on the surface. Now, it only exists in the form of water ice. You can find it just under the surface of the planet in its polar regions. The only place where this water is visible is at the North Polar ice cap. Also, sometimes, salty water flows down crater walls and hillsides, and there are tiny quantities of water in the planet's atmosphere, but it only exists as vapor. So, as a vacation spot, I think I'll pass.